Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today, we are going to learn applications of Varactor diode. So let us see the overview of today's presentation. Start with introduction, followed by applications of Varactor diode. So what are the Varactor diode used in the tuning circuits, and conclude with the summary. So coming to the introduction of Varactor diode is a type of diode that has variable capacitance that changes with the applied reverse bias voltage. So we have a PN junction diode like this, P side and N side. So this is P type and this is N type semiconductor material, anode and cathode. So this is depletion width. So depletion width can be represented with W, and these plates are these depletion width, walls of the depletion width can be treated as normal capacitor plates, right? So from this we can represent, this is analogous to the capacitor, so this represents the capacitive effect. So by changing the width, the capacitance also changes. So width is increases, the capacitance decreases. So because if you apply reverse bias voltage, so obviously by increasing the reverse bias voltage, the width of the depletion region increases. So the capacitance offered by the PN diode in reverse bias condition is given by CT, transition capacitance, which is given by epsilon A by W. So what is epsilon? Epsilon is the permittivity of the free space between two plates, and area is the area of the plate, and width is the width between two plates or depletion region width. Okay, it's a voltage dependent semiconductor device that is used as a voltage controlled capacitor in tuned circuit like oscillators and filters. So the basic application, the best application of these diodes are voltage controlled capacitor in tuned circuits like oscillators and filters. So in oscillators, so usually oscillator doesn't require any input voltage, but it has to give proper sustained oscillations. So otherwise, so there is no damping. Damping should be avoided. So in order to maintain proper sustained oscillations, we use so robust components. So this kind of Varactor diodes can be utilized for oscillation, for making oscillations, and then can be used in filter circuits, because if in filter circuits, so we have to reduce some unwanted component, unwanted frequency components. So in such case, this kind of tunnel diodes are utilized. Varactor diodes are used to replace variable capacitor that need to be manually adjusted to change their capacitance. So in olden days, variable capacitors are used to vary the capacitance. So for that, we have to adjust the capacitance manually, but this variable capacitance is replaced by Varactor diodes, which is variable capacitor diode. They are also used to provide voltage controlled variable capacitance to radio frequency circuits. Varactor diodes are also known as varicap diodes, voltage variable capacitance diode, tuning diodes, and variable reactance diodes. So all these are different names for variable Varactor diodes. So applications of Varactor diode. So they are very much used in as voltage controlled oscillators. VCOs. So VCOs are used in phase lock loops, that communication systems, and varying voltage across the Varactor diode, the capacitance changes which leads to the change of the frequency in the oscillator. So here again the frequency related with capacitor, so capacitance. So capacitance changes, correspondingly frequency also changes. So frequency oscillations can be controlled by changing the capacitance of the Varactor diode. So this will be useful in voltage controlled oscillators. And frequency modulation tuning in radios. So we know radios, we have to tune particular band of frequency. So FM 97.5 like that. So in such case, there must be frequency modulation. So frequency modulation means what? So changing the parameter of signal. So changing the parameter of particular signal, message signal according to the carrier signal according to the message signal. So for example, message signal, let us say I have a message signal like this, so which has very low frequency. So it has to be modulated. So it cannot, if you want to make this signal to be traveled for far distances, it cannot travel far distances because low frequency. And so for that we have to use some carrier frequency, high frequency. So adding this high frequency carrier, that is carrier means which carries your message signal and it will travel far distances. So that is called modulation technique. So in modulation, frequency modulation tuning in radios. So frequency must be varied accordingly to have some specific channel. So are also used in RF circuits by varying the voltage across the Varactor diode. We can adjust the resonant frequency of the tuning circuit, which we allow the tuning in FM radios. So capacitance changes, voltage changes, capacitance changes corresponding frequency changes, and frequency changes means which we want, which frequency we want can be controlled or can be achieved by changing the frequency, by changing the capacitance. So capacitance changes, frequency changes. So that is the advantage of Varactor diode. So phase shifters are also implemented in phase array antennas. So few antennas, so nowadays phase shift array antennas, phased array antennas are very advanced kind of antennas. They have many advantages. Automation takes place in this kind of antennas due to this phase shifters. So the phase of the signal can change by changing the, so for specific application, so beam angle, the radiation from the antenna can changes. It's a phase shift can be changes, right? So varying the capacitance in the certain part of the antenna array can lead to controlling the phase of the emitted signal, which can be used for beam steering and shaping. So usually beam steering, so this is different kinds of antenna array. So antenna array means more than two antennas are combined together. So let us say, so this is antenna 1, antenna 2, antenna 3. So different kinds of antenna. So combinedly it gives one radiation pattern. This gives radiation pattern. Okay. So combinedly the array antenna, this gives an array. So array antenna gives different radiation pattern. So combining together, so you can be combined by using this kind of phase shifters, and then so the can be control the phase of the emitted signal, which can be used for beam steering. So beam steering means this is the beam, main beam. So if you change the phase of this particular antenna array, they can change the direction of the beam. So it can be changed like this. So this is the beam steering concept, and they can also be used in voltage controlled filters. Used in voltage controlled band pass or low pass filters, the cutoff frequency of the filter can be adjusted by varying the voltage across the Varactor diode. Varactor diode particularly used in tuned circuits. So this is the circuit diagram set up for Varactor diode, which is used in tuning circuit. So used in tuning circuit to adjust the resonant frequency. The diode D1 and D2 provide variable resistance in the parallel resonance circuit. So here diode D1, D2 provide variable resistance in the parallel resonance circuit. VC is the capacitance, is the DC voltage used for controlling the reverse voltage of the diode. So here we are using variable DC voltage which can control the reverse bias voltage of the diode. The two diodes are connected in reverse, that is their cathodes are connected with a variable. If you observe, the cathodes are connected here in opposite. So this variable DC voltage is used to vary the capacitance of the both the diodes. So the capacitance of the diode, this Varactor diode, can be controlled by this variable DC voltage. The L inductance of the circuit, and it is usually the inductor is for tuning purpose. So actually this is an RLC circuit. So RLC circuit, here the inductor and capacitors are complex matters. So in RLC circuit is used for the tuning purpose, tuning circuit, tank circuit, you can say LC tank circuit. And then the resonant frequency of the circuit is expressed as C1 and C2 is the maximum voltage. See here, this is the resonant frequency circuit. Frequency of the resonant circuit, that is 1 upon 2 pi root LCT. So CT is the total temperature that is given by C1 plus C2 here by C1 C2 by C1 plus C2. Voltage capacitance of the diode, maximum voltage capacitance of the diode is C1 C2. So here we have C1 and C2, two diodes are there. So in such a way that we can able to get the sustained oscillations in a tuning circuit. So this is the another advantage of Varactor diode in tuning circuit. Now let us see the characteristics of tuning Varactor diode. So obviously we know as capacitor voltage, reverse bias voltage. So on left side you can observe reverse bias voltage increases, the capacitor CT, transition capacitance, increases correspondingly. So as we increase reverse bias voltage, capacitance also increases. The graph shows that reverse bias voltage increases, depletion region increases, and capacitance of the diode reduces. And it is known that capacitor and width have an inverse relationship, just we have discussed, which means that as the width of the depletion region increases with the reverse voltage, the capacitance decreases. In short, as the reverse voltage increases, the transition capacitance falls rapidly. And this behavior can be describing as an exponential pattern. So you can observe the pattern is an exponential pattern. So as reverse bias increases, corresponding capacitance also increases. So what are the disadvantages of Varactor diodes? So more specifics. The designing of these diodes is done to operate them in reverse bias, hence they are not useful for forward bias. So that is another disadvantages. Non-linear behavior. So if you observe the character, just now we have seen the characteristics of a Varactor diode, so in which there is a exponential decay in the capacitance. So it is non-linear. So the major drawback of this diode is a non-linear capacitance voltage relation, which can result in distortion in many applications. So if the reverse bias voltage is increases, the capacitance also decreases like this. Sensitive. The capacitance of this diode is largely affected by temperature variations, thereby making it temperature sensitive. So temperature, environmental changes. For environmental changes, there is a change in the properties of material. So hence it is sensitive to the environmental changes. So the property changes. Once the property changes, obviously the performance of the particular circuit also changes. So that's all for today's session. So today what we have learned, we have started with introduction to the Varactor diode, and we have seen different applications of Varactor diode, and particularly we have discussed what is the use of Varactor diode in tuning circuits, so which are useful in radio frequency, radio communications, and we have also discussed the characteristics of Varactor diode, and we have discussed the disadvantages of Varactor diode. So that's all for today, and the next topic will be probably Schottky diode. Thank you.